Okay, so we talked about in algebra how product sum puzzles, it's very much like just, solving riddles. So you solved that one pretty quickly. I'm going to give you another one. Let's see if you can figure that out. I'm thinking of two numbers, and when I multiply them, I get a product of 9, but when I add them, I get a sum of 6. Yes. Okay, so right away, hands went up. And we're always at different points in the stage where, when you learned your times tables in 3rd grade, they stuck with you. There are some people who I still see doing some nines tricks on their fingers and all this stuff. So the bottom line is, if it doesn't come to you right away, you still have the opportunity to figure that out. So my question is, for those of you whose hands shot up really, really fast, what did you focus on first? The products or the factors of 9, or did you focus on the sums that you could get 6 from? Okay, why? That's great. That's exactly what I wanted to say. Why did you focus on this products first? Yeah, there's really not a whole lot of ways. If you sat here, and I know 6 isn't a huge number, but if you sat here all day and started to list all the ways that you could get a sum of 6, it's only 3. But what if that number was 24? Are you going to sit here and say, well, 1 plus 23 and 2 plus 22 and 3 plus 21? And that doesn't even count any of the negative numbers that could give you a sum of 24. So is it safe to assume that if I want to know what the product of a number it is, I'm going to go with the factors first? And Malachi says, well, I know the only way you can get 9 is by doing those two. So that's where his brain went first, okay? And so then where does your brain go after that? Your brain says, well, I know it's one of these two. Well, then duh. If she wants it to be 6, 1 plus 9 is obviously not 6. So it's not 1 and 9. So you figured out real quickly by doing some fancy math in your head that was the case, right? So if I were to give you this one and say I'm thinking of two numbers, and when I multiply them, we'll go in this product, I get 7, but when I add them, I get 8. That's super easy. 7 is a prime number. There is only one set of factors, so it's got to be 1 and 7. Okay? Now, a little bit of a game changer here. I'm thinking of two numbers, and when I multiply them, I get 20. But when I add them, I get -9. And that, still, some of you are like, I got it. But that negative changes it a bit. So take 30 seconds at your table and kind of walk through it with the brains around you. I'll see you in just a little bit. I'm sorry. Yeah. All right. Anybody got it? What do you got, Ari? Good. Okay, so stay with me, because when you come in here Monday and watch the notes for 7-5, if you don't get what we're doing right now, 7-5 is going to be tough. Okay, so the first thing he started to do was think of all maybe the numbers or the factors of 21 and 20, 2 and 10, 3 and nothing, but 4 and 5. So we're okay with that. 3 sets, right? Okay, and you're at two different points. There are people who don't even need to write them down because they just kind of pop into their head, and there are people who may need to write them down. That's okay. So now, that negative being there is a little bit of a game changer, because I could take any one of these numbers that I'm looking at right now and multiply them and get 20, but none of those together are going to add to give me -9. There's a set that if I add them, it'll give me +9. Okay? So what are you knowing that you need to do with both of those numbers? Make them both negative. Okay? Does adding them both as a negative change the product? No. But now that they're both negative, can I get a -9 as a sum? Yes. Okay. So I want you to look at the first set of problems that I have here on the notes that I passed out. We're going to kind of do it as an X now. So in the X, and I'll transition you on Monday to how we use the X, the top number that you see is the product, the bottom number that you see is the sum. Number 2 is a piece of cake. What, two numbers, when you add them and multiply them, give you, yes. So we know that those answers are 2 and 2, okay? Let's take a look at number 6. We're going to kind of hop around. 6, we're going to go right for the factors first. So 6 is either 1 and 6 or 2 and 3, okay? Good. So first thing I want to point out is what? if your product is positive, whether it was Miss McClendon or Mr. Seville or whoever taught you about your negative rules, or Mr. Meeks or whoever, what is the first thing you know about a product if it's positive? You know for a fact that the two numbers you multiplied are the same sign. Okay? They're either two positives or two negatives. I know you know that. You would not have made it this far in advanced algebra if you didn't. But that doesn't help me because I need to know now if they're both positive or if they're both negative. Where do I look? I look at the sum, right? Because if you add a positive and a positive, you don't get a negative. So I know that if that product is positive, A, they're both going to be the same sign, and B, it's going to be whatever sign the sum is. Okay? Yes. Yes, go ahead.
So it'd be -3 and -2.
Yes, -3 and -2. And I'm glad that happened because I wrote the -2 first, and then it doesn't matter. Those two spots, you can put them in either place.
I think I know the answer to number 3.
Okay, good. Now you're already thinking. So the first thing before we do anything else, I want you to kind of put a little arrow up here under where product is, and I want you to make sure you know two things about that. If that product is positive, what do we know? We know that the signs have to be yes. Step 2. How do you know what those signs are then? You look at the sign of the sum. Whatever sign that sum is, if the signs are the same, the only way to get to a positive sum is if you add two positives. Okay? A negative plus a negative is still a negative. Got it? So let's take a look at number. There isn't another one like that, but yeah, that's okay. So if you know that that is a positive, make them both the same, whatever's there. Okay. Game changer. When you get to a number like, say, number 3. Okay? How many of you, you know it? You don't even need me to teach it to you. Jason, what is it? Okay, good. Now, he's right there. Is it 3 and 10?
No.
Okay, and I'm actually really glad that this happened. So watch. First thing I want you to look at is if your product is negative, what do you 100% know for sure? That the signs have to be different. So go ahead and put a plus and a minus right from the get-go. Okay? So, but watch. This is a really tricky one because 1 times 30 is 30, 2 times 15 is 30, 3 times 10, and 5 times 6. Now, I chose this one on purpose because it proves an example. Whatever numbers you put here, when you multiply them, it's going to be negative. But what do you really do when you have a positive and a negative? Do you really add them? You really subtract them. So 3 and 10 look like a very appealing set of factors, but it's not the ones we need because when I subtract 3 and 10, I get 7, and I don't need 7, I need 13. So which set looks a little bit better? Okay, now pause. Now that we've figured out that it's 2 and 15, I still have a little bit of a dilemma because I have to figure out which one I should put with the plus and which one I should put with the minus. Explain it, Seth. Yes. Yeah. So he says the 15 has to be negative, and his answer to why would be, well, when you subtract, you take the sign of the larger number. And if I need to make that 13 negative, then I better put the 15 with the negative. 1 second. If I were to accidentally mess up and make it positive 15 and negative 2, here's what somebody might mistakenly do. Because if you mess these signs up, does it mess up the product?
Yes.
It doesn't mess up the product because guess what? In a product, does it say the sign of the larger blah, blah, blah? It says as long as one's negative. And is 15 times negative 2 negative 30? Yeah, it is. But is 15 plus negative 2 negative 13? So that's how you know where to put the number, okay? So the 15 has to be negative and the 2 has to be positive. Let's take a look at number 5. You may or may not need to do all the factors written down. What are all the factors of 24 that give me 24 when I multiply, but give me negative 5 when am I going to add them or subtract them? I need to subtract the 2. Because when I have a positive times a negative, you don't add, you subtract. So, I got, listen up please, 1 and 24, 2 and 12, 3 and 8. Hey, is the difference between 3 and 8 also 5? Do I need my sum to be negative? So put the 8 here. This is not bad at all, is it? Okay. I do want to explain, let's do number 7 real quick. 2, and then we're going to do number 4. So go ahead at your table, take 15 seconds. Some of you are already like, boom, I know it. Write it then. You're doing number 7. All right. So, it all has to start with your product. Is your product positive or negative? And if it's negative, guys, it's a positive times a negative. Well, obviously it's going to be 15 and 1, but I need that to be negative, so I'm going to put the 15 here. Okay. So, here's what's going to happen when you get to ones like, say, number 80, like number 4. So, sometimes the product is really big. I mean, 84 isn't huge, but you're going to have ones where it's like 270 or 310. And last time I checked, you don't have every factor of 210 memorized. I don't, and I'm the teacher. Okay? So, that's when this little device comes in handy. I need you to know how to check factors using a calculator. The calculator is useless to you if you don't know what buttons to push, right? So please watch. So I need 2 numbers that when I multiply them, I get negative 84, but I need to subtract them to get a positive 5. Okay, 1 second. So I'm just going to start by taking that number and dividing it by 2 and seeing what I get. 84 divided by 2 is 42. So look at 2 factors of 84 are 2 and 42. Well, man, when I subtract those, I get 40. That's nowhere close to 5. Let's keep going. So I could do, and this is where you kind of use some common sense. If you divide it by 3, there's still going to be a big gap, right? Because the difference of 28 and 3 is 25. So maybe keep going. 84, let's try divided by 6. What's the difference between 14 and 6? 9. We're getting closer. So let's try 84 divided by 7. What's the difference between 12 and 7? There you go. Here's my point. You may not know it off the top of your head. You might. Great. Good for you. But if you don't, this is going to be a very useful tool. So now I need to know which one's negative. The 7 is negative and the 12 is because I need my sum to be, yes. It does not matter which side the 12 and the 7 are as long as the 7's negative and the 12 is positive. Ashton.
Does this have anything to do with 7-5?
This has everything to do with 7-5. You are not going to be able to even start 7-5 if you can't do this. So that's why it's really important that you learn this now, because on Monday, when you put those notes in and watch those, you're going to be like, what? How did she get those numbers? Okay? Yes.